Give you a little different perspective on the cosmic loneliness predicament. There's this wonderful picture book by this Hungarian author that starts off with a image that each page that you turn in the book, you zoom farther and farther out and see much broader what the first image was telling a story about. It's a wonderful book to get a sense of scale as you zoom away from something. And even more wonderful is the name of the book that followed. It wasn't a sequel, but it was very similar in theme, that it was a picture book that each page you zoomed farther and farther out. And the wonderful name of the book second is Resume. You have to love that. Wonderful. Highly recommend these picture books to look at and get a sense of zooming out. And then, read the book backwards to zoom in. Here is a student-made Zoom book, a project I often have students do. And here's one from a student as we zoom out. So this is in the theme, in the style of the Zoom books. For this Where Do You Live page, you're going to create yourself an address for someone who were to deliver this from you if you are somehow on the outskirts of the universe. And the universal postmaster just happens to pass by you and agrees to take your letter to your loved ones back on Earth and let them know you're safe and sound and will be home safely and soon with tales of your adventures of the universe travel. So you're going to address this envelope. You put your name, street address, city, so on and so forth, and keep going so that the letter comes from you, where you've met the postmaster of the universe, and they are going to look at all the details that you've put on this envelope, and they're going to work backwards. They're going to go to the different celestial reference points you've given, zooming in smaller and smaller and smaller and smaller till they get to your home address. And they're able to do this because you were able to list such good details and reference points of celestial objects and things getting larger and larger as you got out from the universe. So you're making a message that you're zooming out from. For example, zooming out, larger and larger reference points. And then on the reverse, the postmaster is looking at your reference points and going smaller and smaller and smaller and smaller and smaller, zooming in closer and closer and closer to the home address that you have listed. Zooming closer and closer to your home. Oh, maybe too close. Because it's probably been, maybe never, that you've addressed an envelope. Here are some to give you an example. So, astronomy teacher at the school, street address, state, city, state. You don't have to worry about the zip code. I'm really including this as an example, not to help you address, but so you see I've gotten a letter from the Harvard Smithsonian Center for Astrophysics at one time. Stanford has emailed me. And wherever I go, wherever I end up, Harvard's able to find me. So where do you live? Press pause, take some time, and put your local address and zoom out and go beyond, 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 beyond until you can't think of any other celestial reference points to give that postmaster. So I'm going to give the school address as the example. So the street is 180 North, 300 West. And after I give you the address, I'll give you an example of what that celestial body, as we zoom out, reference point looks like. So there's our wonderful Ridgeline High School. It is located in the city of Millville. Welcome to Millville. We're in the county of Cache. And we don't necessarily put county on the envelopes. I just decided to throw this one as a zooming out larger land area. And this is Cache County within all the other counties. Those of you who had Utah Studies course may be singing the county song in your head. We, of course, are in the state of Utah. When I first found out I was moving here, I looked at Utah and thought perhaps it spelled hate you backwards. The outline of the state of Utah. The History Channel has a great series of the state, how the states got their shapes. Fascinating history about this area right here not becoming part of Utah. We are in the country of United States of America, the USA. Right there in Millville, and I only have the contiguous US of A listed here or shown here. We are on the continent of North America. There is the North American continent. Hemisphere, tend not to think of too often, but we are part of a 2-for-1 special. We are part of the Northern Hemisphere and the Western Hemisphere. So I combine this, of course, into the Northwestern Hemisphere. Here you're seeing the Western Hemisphere and just a portion of the Northern Hemisphere. We, of course, are on planet Earth, some cultures called Terra. When the first child is born on Mars, we will have to add planet of birth to our passport. The planetary region. We are in the inner planet region. There was that huge swath of real estate separating the inner and the outer planets. Now this image certainly isn't accurate for distance, but it is fairly accurate for the size of these terrestrial planets. The planetary system we're a part of is the solar system, named after our central star, Sun being the nickname, Sol the proper name. Again, relatively appropriate for size, but not for distance scale. The cloud that we live in. Now, some of you might be familiar with the Oort cloud, but I'm actually going beyond the Kuiper and the Oort cloud area. I'm going much zooming farther out, and you're going to love the name of our cloud. We are living in the local fluff. I know you would love it. We don't necessarily mean cloud in terms of a rain cloud. We mean cloud in terms of area of activity. And by activity, we don't mean high energy, we mean mass. There's a lot of mass in this concentrated little area. So this area is our cloud, and ours is known as the local fluff. If we zoom out further, we have the cavity. The name of our cavity you will like as much, maybe more, than our local fluff. The name of our cavity is the local bubble. So the areas where there's less activity, remember meaning celestial bodies, mass, matter, that is our local bubble. So this kind of bluer area is the local bubble. And here's another perspective of our local bubble. Our neighboring Pleiades bubble. The galaxy might be your thought for zooming on out beyond that, but actually we don't live on one of the major spiral arms of our galaxy. We are part of the galaxy spur. And I think you'll like the name. We are on the local spur. So here is the local spur. It's not a major arm of the Milky Way galaxy, but this is where the solar system is located. When you get to this size of things, sun really represents a little dot for our whole solar system. Here's the major arms, highlighted again. The name of our galaxy, many of you are familiar with, is the Milky Way. And as I've been showing you images for these celestial bodies, I thought what better image archive to go to than nasa.gov. They have a wonderful digital library online. And this is the image that I did find at nasa.gov for Milky Way. That's awesome. Another equally awesome image I found at nasa.gov was their image of the discovery of water on Mars. Not from nasa.gov, but another way of thinking about the Milky Way. An artist rendering of the Milky Way, because all images of the Milky Way are artist renderings. We've not been able to send a camera on a space probe far enough outside of our Milky Way galaxy to turn around and say smile, say cheese. So these artist renderings are based on data. We're able to calculate and measure where the density of stars are, and we know that our galaxy is very similar to our neighboring galaxy Andromeda. So they're not wild guesses in these artist renderings. They're based on the scientific evidence that we have. It's more textbooky, if you will, look at the Milky Way galaxy. That we are here on the spur of the Milky Way. It's an image taken from central Utah. Looking out through here of this cave, you can see a band, an arm of the Milky Way. Looks like a maybe cloud in the night sky, but it's a band, an arm in the Milky Way. And I say an arm because let's say this is the sun and we're looking this way perhaps. We're looking into this arm, this denser packed region of stars. Things that make you go, every star that you can see is in this yellow circle of our Milky Way galaxy. Again, to make you ponder, are we alone? Cosmic loneliness. Our solar system takes 225 million years to revolve around the Milky Way. The last time Earth was in its current position, dinosaurs were just beginning to roam the Earth. So the galactic birthday, 225 million years. Our sun is 20 years old, as it's completed 20 revolutions around the center of our galaxy since it formed. From an Earth perspective, we call 1 year one revolution of the Earth about the sun. If we think about this term of a year as being making one trip around the center of what you're revolving around, like the Earth revolving around the sun has revolved around the galactic core 20 times. That's what's being meant here by saying our sun is 20 years old. So galaxies form groups. Now, I don't necessarily mean forming groups in the sense you have two sand piles and they form a larger sand pile together. This is the idea of zooming out, and you will see neighboring galaxies. The name of our galaxy group is the local group. Using Google Earth to try and emphasize this idea, let's think of this football field as one galaxy, and this football pitch, soccer field, as another galaxy. They're their own independent celestial bodies, but as you zoom out, they would form a group. If this was our galaxy group, it would be the local group. Now, instead of football pitches and fields, we have the actual celestial bodies, the Andromeda galaxy, our closest neighboring galaxy, and we have the local group. There's another image where the center dot represents our Milky Way galaxy, and then our local group, and then other groups of galaxies in the light blue. Galaxies then form, or galaxy groups then form clusters. And again, it's not a group of galaxies and a group of galaxies combined. It's this zoom out. The name of our cluster? Local cluster. So So just as you have cities, as you zoom out, so Logan City, River Heights, Providence, Millville, this would be like your clusters of where people live in cities. The center now, instead of our Milky Way, being the local group. Now, galaxies contain from low end of 150 billion stars upwards to about 450 billion stars. Think about this dot representing our local group, or say 3 or 4 major galaxies. Let's say each one of those had 300 billion stars, and just conservatively, let's say 3 galaxies. So 3 times 300 billion. This one little dot here is representing 900 billion stars. All of these these dots representing hundreds of billions of stars. As you zoom out, clusters then form superclusters, forming in the sense of as you zoom out, not a cluster combining with a cluster. The name of our supercluster, this is where you want to be careful not to jump too quickly into patterns in science. Our supercluster is known as Laniakea. And zooming out, maybe we would consider superclusters compared to counties. So Bear River County, Box Elder County, Cache County, Davis County as our superclusters. Now, looking at the supercluster, a model, a representation of the supercluster, this would be a piece right here of our wonderful Milky Way looking out from this supercluster of Laniakea. Milky Way, our supercluster. I'll show you a short clip to introduce you to Laniakea.
Somewhere in the universe is a small blue planet, the third rock from a star called the Sun, just one of billions of stars in a spiral galaxy known as the Milky Way. But where in the universe is the Milky Way? A team of scientists gathered data on more than 8,000 of the galaxies that surround us. They mapped each galaxy's position and movement in space. And, for the first time, they've shown that the Milky Way is part of a much larger system of galaxies, a supercluster that they have named Laniakea. The Milky Way is nested in the furthest reaches of this structure, on the outskirts. The entire universe can be seen as an intricate network of galaxies, a cosmic web. Some areas are almost empty, dark voids. Others are densely packed with galaxies in regions known as superclusters. Superclusters are the biggest structures found in the universe, but scientists have struggled to define where one ends and another begins.
And how the scientists come to reckon with this is something we'll explore further. We need to get a little bit more science into you before we consider that pursuit of how we've come to discover these wonderful superclusters. So that'll take us to our final postage marking of our universe. Now this course is called Astronomy the Universe, uni meaning one. We're not going to go into the depths of multiverses. We just don't have time within the course to do so. I mean, we really don't have time to cover the whole universe in this course, but we're going to stick to one universe. We will look at multiple dimensions within our universe, but we have one universe within the concept and confines of our class. There is no proper or official name for our universe, although there are a lot of adjectives that often precede universe, like observable, visible, or known universe. Perhaps one day this will be Google Maps in the future, observable universe and Laniakea at the center. Actually, we're not too far away from this in the sense that we do have 2 individuals that are doing an enormous amount of work to help us establish what does our universe look like. First one here is Margaret Geller. Her last name is Geller, G-E-L-L-E-R, G-E-L-L-E-R, Margaret Geller. And she, with her research partner of John Huchra, H-U-C-H-R-A, Margaret Geller and John Hookra have devoted an enormous amount of their careers to mapping our universe. This right here is Earth at the center, not necessarily meaning the center of the universe, but Earth at the center of the way in which we're looking out to our northward skies and how we're looking south at our southward skies. These little areas that we don't see a large presence of stars is because of the effect that we are in the Milky Way. And this will be looking into the bands of those dense regions of the Milky Way arms. So this area, the zone of avoidance in the green here, because we're not able to see through this thick, dense coverage of stars. So we're able to map above us in the northern sky and below us in the southern sky. This right here is a very large structure. It has been given the nickname of the Great Wall. When the southern data started to come in, this one was first called the South Wall, and then it was later named after a great scientist, Sloan, the Sloan Wall. You know you've made it big in the world of science when the material you have researched and collected and gathered is on display in the Smithsonian in Washington, D.C. And here is the telescope in which they began to create the first three-dimensional map of the United States. And again, those names are Geller and Hookra. Why couldn't this photo be in focus? Because I took it, and that's just my natural photographic talent. When people on airplanes ask me what I do, I used to say I was a physicist, which ended the discussion. I once said I was a cosmologist, but they start asking me about makeup, and the title astronomer gets confused with astrologer. Now I say I make maps. I have done this experiment myself on airplanes, depending on the mood or whether I want to chat to someone, and if I say I'm involved in physics, it does shut down the conversation immediately. Cosmology, this is a branch of astronomy we'll explore in an upcoming unit. And if I want someone to talk to me in a flight, all I have to do is say that I'm a language arts teacher, and people will immediately start to share with you their favorite book, their favorite poem, their favorite English teacher. Whereas mentioning you're involved in physics, and particularly if I were to say nuclear physicist, that immediately ends the conversation and I have a nice peaceful flight. But Geller, to say that she makes maps is definitely an understatement, as she has begun to map the universe.